So one thing that goes on is these tables have a relationship. You notice that before we had customers had many different agents, but a customer only had one agent, but agents could have many customers. And these are called relationships between objects. And so when we talked about our entity object model previously, we had four main objects. We had entities, attributes, constraints, and relationships. Um, well, relationships basically deal with the relationship between objects. So a one-to-many relationship, which you find quite often, um, could be a thing like parks and trees. A park contains many trees, but a tree is in only one park. I'm trying to put this in kind of GIS type terms. One-to-one relationship should be rare in any relational database design because if it's one-to-one, you could just append the fields, unless there's some reason why you shouldn't, such as you don't own the other table and so you're prevented security-wise from editing it. Or it's some classified information or something. You have a one-to-one relationship between your S number and your social security number. Maybe you don't want people at the school to be able to see the social security number, but you might want to see the other information associated therein. Because they have to use your social security number when they're reporting scholarship stuff and what have you. The other relationship is many to many, and this is common as well. The one that I deal with all the time is parcel. We have an owner table, people who own parcels, and then we have parcels, which are geographic shapes. And a person can own many parcels, but a parcel can be owned by many owners. So we have a many-to-many relationship. This is hard to implement in a relational model, and so generally what we have is an intermediate table, and we'll talk about that in a second. Okay. So one-to-one relationship, a painter paints a painting. No, I'm sorry, this is one-to-many. A painter paints a painting, and then talk about this. We talk about business rules, etc. A painter paints a painting. You look in this direction. A painter paints, and then because we have the crow's foot here, many paintings. Painter may paint many paintings. But every painting is painted by only one painter. So when you look at this ERD thing here, we have the case where we need to explain this, put it in English or some language, and to do that you need to identify an instance of a painter and an instance of a painting. All right? You can kind of think of those as records. So one record in the painter may relate to many records in the painting. A record in the painting table relates to only one record in the painter table. Okay, oops, what did I do? I get that? Okay, there we go. So this is kind of how this would look. A painter number 1, 2, 3. He paints painted more than one. Yeah, that's Bob Ross. Oh, Georgette Ross. Okay, so if you find out that you have a one-to-one relationship, it may be that was not originally defined correctly, or they belong, certain requirements. It's a specialty kind of deal. One relationship between, say, you have a table full of professors and a table full of departments. Well, a chair a department has only one professor as a chair, and a professor may only chair one department. Does this mean that all professors chair departments? No. Does it mean that all departments have a chair? Well, in this situation, it does not necessarily say that. So now we get to the many-to-many relationship, and this is a case where you're going to have to kind of artificially construct some things, because the concept of many-to-many is great in a conceptual model. Remember, I don't know if you remember in the modeling discussion, we talked about conceptual versus physical. But once you go to implement it inside a database management system, it doesn't work real well. And it doesn't work real well in ArcGIS software either. In this example, a student has many classes, right? As a student, you may have many classes. And every class may have many students, right? So how do I know which student is in which class? And that's where we insert a table between the two of them, right? And in this case, we've created a table called enroll. And this is a linking table. Basically, its function is to break a many-to-many relationship into two one-to-manys. Student to enroll is a one-to-many. Class to enroll is a one-to-many. And so basically this way you can tell who's taken what, right? Bowser, if you think about it, in this student table, if I put Bowser, I couldn't put a field out here for a foreign key to over here because he's taking more than one class, right? So I couldn't put 10.00.14, 10.00.18, 10.00.21. I guess I could if I made a whole bunch of fields and said class 1, class 2, class 3, but then now I have limited how many classes they can take. And then the same thing here with class. I could put student 1, student 2, student 3, student 4, up to student 500 or whatever. But that's, it's a waste of time, a waste of space for many of the classes that don't have 500 students. Anyway, so what we've done is we've stuck this table in between them called enroll. This is a linking table. And the way to find out what classes student Bowser takes is we take his primary key. We go look it up. Let's see, 321452. Okay, there he is. And there he is. And there he is. So he's taking class 10.014, which is accounting. He is taking CIS 220. And he's taking, is that QM? QM 261. You'll notice in this table, now this information is only about the class itself, right? It doesn't list any of the students. It only lists the class itself. So really, these two fields, class code and student number, neither of these is a primary key, but because there's duplicates, but they allow you to get from one table to another. In addition, they allow you to enter attributes for things that are unique combinations of these two tables. So for the combination of Bowser and accounting, we have a grade of C. Maybe it's requirements, right? Or prereqs. Does he have the prereqs? I'm going to go and enroll. Do you have the prereqs? Yes? Okay, you can enroll. You don't? Okay, you can't enroll. But the question is the combination of student and class. Does that combination have a prerequisite? All right, so linking table, and then basically it looks kind of like this. Instead of change a many to many into two one-to-manys.